Find two positive integers, x and y, such that their sum is 20 and the sum of their squares is a minimum. Enter the function you want to minimize. A equals what? So we need to determine what this function will look like. So we're trying to find two positive integers, x and y, so that their sum is 20. So let's write that down. So what we need is x and y such that they add up to 20, and the sum of their squares is a minimum. So and x squared plus y squared is a minimum. Okay, so the function that you want to minimize. The function that we want to minimize is x squared plus y squared. So that's what was stated in the problem. Enter the constraint equation. So the constraint is what relates to two variables and gives us a point where we could have a maximum, because if we can just allow x and y to go to infinity, the area can go to infinity. So we have to have some sort of constraint. And that, in this case, is that x plus y has to equal 20. All right, plug the constraint into a of x and enter the new function a of x. Okay, because right now this function is a of xy. It's a multivariable function, which we don't know how to deal with currently. We need to rewrite the constraint in such a way that we can plug in the constraint into our original equation and get it down to just two variables, the input variable and the output variable. And that's easy to do. It doesn't matter which variable we choose. I'll pick y and let y equal 20 minus x. And then knowing that, so I have a of xy defined as x squared plus y squared. But y is going to get replaced with 20 minus x quantity squared. So I've plugged in my constraint, and that is my new function. And that new function, we can work with it, we can manipulate it, but that's a perfectly valid representation of the function that we want to minimize. Now it says to find the derivative. So I could probably multiply this all out and get the derivative, or I could just use the chain rule, it looks like. So this would be 2x plus 2 times 20 minus x to the first power times the derivative of the inside, which is negative 1. So this would effectively be, let's say, 2x minus, let's see, because 2 times negative 1 is negative 2, but times the 20, so negative 40. And then this would be plus 2x. So I'll go ahead and simplify it and say, whoops, I wanted to write 4x minus 40. Find the location where a of x is minimized. Okay, so a of x is going to be minimized whenever its first derivative is 0. So if I take 4x minus 40, set that equal to 0 and solve, then 4x equals 40, or x equals 10. And the thing about that is I'm not guaranteed that that's a minimum and not necessarily a maximum. So you want to have some sort of logical reasoning as to why you know that it's a minimum versus a maximum. One way is to get a second derivative, if a second derivative is easy to get. So the second derivative here would just be 4, which is always positive. And if the second derivative is always positive, that means you have a curve that is always concave up. And so any critical value you come across would have to be a minimum. So that pretty much verifies that this is definitely a minimum. So at x equals 10, and then find the minimum value. So the minimum value itself would be the function evaluated at 10. So Let's see what we get. So a of 10, since I don't have both x and y at this time, I'll use this form here where I don't need the value of y. So that would be 10 squared plus 20 minus 10 quantity squared, which would be 100 plus 20 minus 10 is also 10. 10 squared is still 100. So the minimum value is 200.